Hello, welcome to CEO's Projects. Today we're going to go over how a scanning algorithm works for keypad inputs. Now, this type of keypad is a normal type of keypad that you would find in most Arduino kits, like this. Just a simple 4x4 keyboard. They sometimes even come in 4x3. So, what is a scanning algorithm? A scanning algorithm is how the microcontroller or the board that you're using tells which button is being pressed. Now, there's multiple ways, but the way how I do it is I use an alternating scanning algorithm. So essentially, all these all these numbers reflect to a pin combination. So in other words, if I want to click this pin, I'd have to travel up this row and down this row. So that means I would use this pin and, following the diagram that was poorly drawn, this pin. So in other words, if I put a high on this pin, or a high logic on this pin, and I'm looking for a high logic on any of these pins, I will know that I pressed this one. Now, you just need to apply that logic for every single one of these lines. And the way how this works is, these pins are always looking for a high or low value, because of the fact that if you press anything here, it will read a high or low value, if you're looking for something, obviously. So, you might say, well then, how do you know if you're pressing this one versus this one? Well, that's the thing. Since clock speeds work so fast, you can alternate between each one of these pins. Just literally say, this pin on, these pin low. This pin on, these pins low. And then for the other two, you do the same. And so what that does is, if we know that this pin is high, that means that only these, or only this column, if pressed, will send out a 1. Or in other words, one of these will read high. So if this is 1, and none of these are pressed, all of them will read 0, meaning nothing's been pressed. Now, if I were to press something here, while this pin is high, nothing would happen because there's no high pin. Now, the other reason why this works is because unlike a super complicated keypad, there's not going to be any backflow of voltage. Essentially, the buttons are disconnected, so they're not gonna, they're not gonna flow through. So, let's say now, I wanted to see if if any of these pins were pressed at the same time. What I would do is, like I've said before, have a for loop or just a constant loop that is switching off which pin is high in the stack. Now, you only want one pin to be high at a time, which is the only flaw of this algorithm, which is the fact that you can really only see one button at a time if it's being pressed. You can't hold down two buttons. So in other words, if you were to press down this button, you wouldn't be able to tell if that button was being pressed down at the same time. You could tell, though, if any of the other row buttons were being pressed at the same time, because of the fact that they correspond to different output pins. These correspond to the same output pins, which is a problem. Now, there are ways around it using diodes, but that's a bit complex. So, what I would do is to see if there's two button presses. What I would do is to see what buttons could theoretically result in a higher output. The only thing is, though, again, it doesn't work, and you need to have variable voltages, or one thing that I theorized was having different resistances on these individual pins. So in other words, if you were to press this pin down, and then this pin down, you would see a higher resistance. The only thing is, though, commercially and just logically, it doesn't really make much sense. So you're really just stuck with only being able to do one row button at a time. But if I had to press down every single one of these, and all of these light up, we would know how it works. So in other words, the algorithm that I suggest, which is turning on one input pin at a time to see which column button is being pressed, is great for basic stuff, but it's not good for anything that requires multi-button presses. Now, yeah. So, well, just an explanation. I did this for a project in 649. I did it as a project, and I just wanted to explain it. So, yeah, right. Thank you for watching.